I have a tendency to talk, so I'm going to ask you to sort of keep an eye on the clock and give me the hook if necessary, because I know I'm the last speaker before lunch, and I don't want to stop the herd, if you will, from grazing as necessary. So first of all, I want to thank you all for allowing me to come to Colloquium and how welcome you all have been. I've certainly enjoyed my stay here and certainly have enjoyed my first Colloquium. And I want to give you a presentation this morning that will give you an outline of what's happening, as Howard says, on the other side of the pond. So I'm going to talk about a couple of things. I'm going to talk about ITAR, because that has a lot of interest, I believe, over here. I want to give you an update of what AMSAT North America has been involved with that. I want to talk about ARISAT, which is the Amateur Radio International Space Station satellite, formerly known as SUTSAT-2, and the development work that's being done. That program is reaching fruition. I want to talk about the status of some of our current satellites, AO7 and AO51, and if we've got time, I want to go into a little bit about our next project called Project Fox, which is a CubeSat. First of all, greetings from across the pond. I moved recently to the state of Massachusetts, or the Commonwealth of Massachusetts, and of course in Boston, Sam Adams beer is the big thing. And for those that may not know, Samuel Adams was one of the signers of the Declaration of Independence, and cousin John became the second president of the United States. And so those were some of the key framers, if you will, for American independence and the early going on of what was happening to become the United States. That's my son Andrew and his wife Lindsay that were visiting the brewery when they came home for Christmas in 2008. So first of all, what is AMSAT? Now I'm going to use the term AMSAT instead of AMSAT-NA because that's what we call ourselves in the United States, and this is a presentation that basically is focused on that. We're a 501c3. That's the IRS Internal Revenue Service designation for being a non-profit with over 3,700 members, including 493 overseas and 130 Canadians that are members of AMSAT. That is down significantly from the heyday, if you will, back in the 90s when we were building P3D and we had over 8,000 members. And about half of those members, or over half of those members, are actually life members. And of course, from a historical point of view, we've been a major resource for technical research and development. A lot of the work we've been doing in conjunction with AMSAT-DL, AMSAT-UK, and ourselves has become, the basis for success in technology. I mean, you think about the success of the microsats launched in 1990 that demonstrated that a 9-inch by 9-inch by 9-inch cube had utility in space. And so in some respects, we're suffering from the results of our own successes, because that small space in a launch vehicle that nobody else wanted, that we took advantage of, now has commercial value. And so we're now being forced to pay for very high launch costs because we've demonstrated through our own successes that there is value in what we were doing. We were incorporated in 1969. We celebrated our 40th anniversary last year at the AMSAT Symposium at BWI. 40 years of accomplishment in space, and of course our own history of amateur radio in space is even greater than that. Oscar 1 was launched from Vandenberg Air Force Base in 1961, so our even longer history of success for amateur radio in orbit. And for those that may or may not know, when Oscar 1 was launched, it was the first payload to be a secondary payload on a launch vehicle. Anybody know what the primary was? We were told it was a space explorer, a scientific payload. In fact, it was a Corona satellite, which was one of the early imaging satellites used by the National Security Agency. So what is AMSAT? We design, build, and operate experimental satellites and promote space education. We partner with a number of different groups and organizations, NASA, ARIS, foundations, universities. We help those with LEO satellites and CubeSats. And of course, we're pushing for technical and scientific innovation and development of spacecraft, but also involving training and development, both for ground station, the operators, if you will, as well as the next generation of satellite builders. So if you may remember, some of you may not know, when we developed our vision statement back in 2004, we talked about having high Earth orbit and a continuous coverage by 2012. That has changed because of the realization that getting to high Earth orbit really is impractical at this point, both because of cost, we're talking multi-million-dollar launch costs that we cannot afford, as well as some of the technical issues we had with building satellites, the Eagle program in particular. So we've now sort of refined our vision statement saying deploying satellite systems, suggesting multiple satellites being available, that with the idea being over time we would always have something available coming over the horizon to operate through. And of course providing them some sort of continuous coverage. Participation in human space missions, this is taking on even a more critical role. We'll talk about that more in a moment. And then supporting now a stream of low Earth orbit satellites as being the focus. First thing you have to understand is I gave you the overview of what AMSAT is as we see it. Now I have to tell you what the United States government sees us as. We are a munitions supplier. Okay? Because by definition, communication satellites are a defense article. And so we've now been thrust, if you will, not into just the issue of building satellites in our garage the way we sort of historically seen ourselves. Now recognizing we have to deal with the world around us and the changes that have occurred, particularly since the mid-1990s with government regulation of communication satellites. So we are a munitions supplier. In fact, we have to renew our license, our export license every year with the State Department to authorize us to export munitions. And a communication satellite, even an amateur radio satellite, is considered a munition. And that has changed the game for us in terms of how we interact with other organizations. And when Congress changed the ITAR regulations, the International Traffic in Arms Regulations, back in the 1990s because of some incidents that some commercial ventures got involved with China, we basically were aware that the rules had changed, but we didn't really understand what they meant, and we couldn't possibly believe that they would affect us. I mean, we're building stuff on our garages. They're not concerned about us. Well, reality hit home around 2007 when Harold Price, who was the developer of the spacecraft operating system for the microsats, wanted to work out an arrangement with Surrey for them to use his SCOS operating software. And it was Surrey that, in their conversations with Harold, that made him realize that perhaps some of the things he had done in the past on behalf of amateur radio may have been in violation of ITAR. So they contacted Harold and gave him the name of a lawyer in Denver, Colorado named Frank Schuchat. And Frank met with Harold and said to him, yeah, you have to basically not only understand the rules, but you have to divulge what you've done in the past and basically try to get exoneration from the State Department through what's called a voluntary disclosure. So he did that process, and from his business that he was managing, he managed to get through the process. And in the process of that success, he started telling some of our AMSAT builders about his experience and basically put the fear of God into our builders about, this is serious stuff, guys. They can put you behind bars and they can fine you an immense amount of money. So that was part of the history that basically caused our American satellite volunteers who were helping with P3E to withdraw, because they heard the horror story from Harold about this is serious stuff, guys. And of course, our intentions were always good, but now the realization was, hey, we have to take a look at ITAR and get real about it. So the impact of ITAR on us has been significant, as we put it on this slide. Suddenly our volunteers withdrew because they were concerned about whether or not past actions would cause them jail time. They were concerned about potential prosecution as individuals. They were concerned about, of course, how do we deal with ITAR in the future? We had no real good understanding or guidance as to how we ought to move forward in the reality of dealing with ITAR. And rather than playing the ostrich with your hole in the ground, your head in the ground, we had to basically come to the realization we had to take some action. So in 2008, we started a serious conversation within the AMSAT board about what actions we want to take. And after I became president, I met with the same attorney, Frank Schuchat, that Harold had retained and who he had highly recommended. Beyond that, beyond the fact that there are regulations and limitations about exporting of materials and sharing information, there's a humongous amount of administrative detail that ITAR requires. You have to document everything you do, log everything that takes place, all emails, all telephone conversations, all meetings, all exchanges. So and what they can get you on is not just whether or not you physically violated the law, but if your administrative procedures are not good, they can prosecute you for that as well. So some of the ITAR prosecutions have been with major corporations, not because they actually did something wrong, but because their administrative processes were questioned and they didn't cross the T's and dot the I's on their administrative process. So the cost of doing business under ITAR is significant, not just because of the procedures, but because of the administrative burden that it places on the folks involved. So we basically took the position, we're going to submit a voluntary disclosure. If you submit to the State Department, the Director of Defense Trade Controls, the fact that you've done something that you may have done wrong, they will review the situation, come to conclusions to what your intent was, and if you were unintentional and they think you will not do it again, they can give you a blessing, if you will, and say, verily, do not do that again. However, if they come across information on their own that says that you've been violating ITAR and haven't come forward on your own, then they will prosecute you. So what we did is we submitted what's called a voluntary disclosure to the Ddtc regarding those areas of P3E that Americans were involved with, starting back in 2003, 2004, involving P3E. Now notice we don't have P3D on here. And the reason is because there was a statute of limitations. P3D was completed basically in 2000. This was now 2008, 2009. So the violations that clearly took place in hindsight for P3D, we did not have to submit because that was beyond the statute of limitations. So we basically documented everything we did for P3E. We submitted copies of the AMSAT journal articles. We had got statements from everybody who was involved. I mean, even Peter was interviewed by our attorneys to get his perspective on what happened and the interaction that took place. Of course, the AMSAT journal had documentation about the various meetings in Marburg that took place with P3E with U.S. volunteers being present. We included documentations like emails and everything else. We basically gave them the whole kit and caboodle, and everybody from the United States who was involved was interviewed. So we submitted we were going to go ahead and submit that, and the idea was that if that didn't work in terms of, that would get us off the hook, but then the issue was going to be, okay, is there any way we can go forward with trying to work out an arrangement with the government that would allow us to continue to work with P3E? So that we wanted to go through several processes, which I've outlined here, as an attempt to try to maintain momentum with P3E. So we submitted our voluntary disclosure after several months of development in January of 2009. 3 months later, the Ddtc came back and said, verily, you have sinned. You have, in fact, violated ITAR, and don't do it again. But we submitted a very large report with 4 different areas of self-disclosure, and they did not tell us what, if any, or all, there was something violated, but which one or all of the things we did were considered to be violations. They provided absolutely no clarification at all, but they said, don't do it again. So, of course, that left us stymied because we weren't sure, what did we actually do wrong, boss? We didn't know. So we went back to the Ddtc in June. The attorney and I actually met with a couple of officials from the State Department to seek advice and next steps. And of course, we point out to them who we are. And from a bureaucratic regulatory perspective, AMSAT is a different animal. You think about corporations, what do corporations have that we don't have? They've got employees. People are getting paid. You have that fist, if you will, of being fired as an incentive for people to, adhere to company policy and do what they're told. What are we? We're a volunteer group with one paid employee who's not even involved with satellite construction. And we end up in a situation now where, volunteers, do you have much control over volunteers? So from a State Department perspective, we are a different animal, and I'm sure that part of their interpretation of what they would allow us or not allow us to do is based upon the fact that they've never had to deal with a 501c3, a nonprofit organization, where there's nobody who's employed, and they're all building something that has something to do with communication satellites. So we met with them, and of course we explained to them that we didn't know what the specific violations were, but we thought that if we went ahead with what's called a commodity jurisdiction request and move the things that were under P3E to the Commerce Department under the EAR, the Export Administration Rules, that would create enough latitude for us to do things with AMSAT-DL and AMSAT-UK and not worry about the specific violations, because now we're going to be under a different set of rules. So we submitted the CJ request, the commodity jurisdiction request, in July. and they came back in November and said no, that everything you do as defined by them is in fact under ITAR, and they're not going to transfer our stuff back to the Commerce Department. So we're back at square one. So then we went and said, okay, we want some advice from them as far as what can we do to make things open, public domain, because anything that's under public domain is not subject to ITAR. So if you publish, then once it's published, it's public domain, and therefore you can talk about it. So we then wanted to know, well, what constitutes public domain? And what turned out to be, the advice we got from the State Department was, they literally want you to publish before it's considered to be public domain. So even though 90% plus of all the interactions taking place is on the internet, email exchanges, blogs, whatever, websites, the whole 9 yards, that is not considered to be public domain. Because in their mind, it is too easy for someone to put something on a website and take it down or play with it or whatever, and that's not really public domain. You have to physically print on paper a publication. So, you have to print in the AMSAT journal. So, of course, we're still stuck in a catch-22 because we can't share information with foreign nationals, except for Jerry. I think you all are foreign nationals in the eyes of the State Department. We cannot actually have any conversations until after publication takes place. So we can't have any joint development work because it hasn't been made public domain yet. So where is AMSAT now with this process? We have spent a significant amount of money on legal fees on this process. And so we must decide what are we going to do now if allocation of any additional resources to try to deal with this export exemption, this DSP-5 that I have on the slide here. The DSP-5, and I sort of overlooked it on the previous slide, in exceptional circumstances, you can apply for a license where you basically ask them to declassify what you're doing, and they're not going to care, so therefore you can have free exchange with foreign nationals. And so, given the work that we've done, can we in fact convince the State Department that maybe we can get a DSP-5 exemption? So the question is, do we want to go through that? Does the approach of getting a DSP-5 really work? What are the prospects for approval? Note that everything we've asked for has been declined. So how much money you spend on legal fees, and compare the probability of success where you'd say that that money was well invested in going for a DSP-5 exemption. So we've deferred additional legal except there's a compelling reason to pursue further. So I had a conversation with Peter this morning asking him, well, do you really need American help at this point? And the answer may be yes. And so now I have to go back and say, okay, are our builders who quit working on P3E now basically 4 years ago, are they willing to go back? If they are, well then I will go to the board and say, okay, we have the volunteers, they want to go back and work on P3E. Should we in fact justify spending thousands of dollars more on a legal process to get permission through the DSP-5 process? And we'll make a determination as to whether or not that's something we can afford and has a reasonable prospect for success. And if all the cards line up, then perhaps we will in fact go ahead and do that. But we spent over $50,000 on legal fees in the last year on this whole ITAR process. Okay. Now, Congress may change the rules. There's been talk about that. People are starting to understand that ITAR has had some significant commercial implications for American aerospace companies. So there's been talk about changing ITAR, but I will believe it when I see it, because that's just the way the legal, the law and the governmental process moves. You can't assume anything until they actually get some law passed. So what have we accomplished for our $50,000? Big thing is we got our people off the hook. There was a legitimate concern that if word got out about our past activities that someone would be prosecuted. Of course, AMSAT organization would have been totally decimated, but our individual volunteers would have been affected. So we cleared the air for both our AMSAT organization and our satellite builders. They created an environment where volunteers now are willing to work on AMSAT projects. I mean, these guys didn't want to have anything to do with AMSAT at all. And so we now have people back in the fold, if you will, because we've taken care of the situation. So what about the future? DSP-5 might be a possibility, though I'm not declaring that today. But it's clear that from an ITAR perspective, we have limited options in exchanging technical information with foreign nationals. You can talk to us. You can give us all your technical information that you want, but I can't talk to you. Okay? So we will push to make our stuff public through publication, primarily through the AMSAT mechanisms of the AMSAT Journal and our AMSAT Symposium proceedings, and publications in QST or CQ or whatever. And we will basically limit our project work to U.S.-based projects or where there's another existing ITAR process in place. For example, NASA and RSC Energia have agreements in place that allow technical exchange. So, I'm going to talk about AeroSat next. That's an obvious place where we can have technical communications under their agreements. And in fact, and we'll see this in a moment, all of our conversations involving AeroSat to date and into the future will always have a NASA employee involved, and they will be on all of our telephone conversations on technical exchanges because we are under their technical agreement. So we're not under an ITAR technical assistance agreement that came from AMSAT. It's coming under NASA and RSC's agreement, and so therefore we're working under their rules and their people. So everything we do, they are cognizant of, so that we are free and clear in terms of any regulatory burden. So let's talk about AeroSat. AeroSat 1 is the former SUTSAT 2. And so why are we doing it? The big thing is educational outreach, because education is the key to rides in the future. If you can provide educational benefit, someone's going to support you. That gets our communications equipment in orbit. So from an educational outreach perspective, we're going to provide a vehicle for student experiments that will be basically put on an AeroSat platform and released into orbit, providing telemetry for those students to analyze. We're also doing, in this case, student messages, where messages are being sent to the ground for students, middle school, high school, whatever, to listen to in various languages. And of course, they need to learn a little bit about orbital mechanics and the science of space technology to be able to take advantage of AeroSat 1 using basic equipment. We will have slow scan TV images coming off which people can download and review as well. So in exchange for providing this educational outreach, we get a free launch. Now I put free launch in quotes because, yeah, we have to build the satellite, we have to transport it to Russia to place it on a Progress vessel, but that's small change, comparatively speaking, to the millions and millions of dollars that it takes to place a satellite in orbit, particularly of this size. So it's our ticket to ride, if you will. And of course, it's a platform for technology development. In this case, we're putting the software-defined transponder, the SDX, on AeroSat. And that'll be the first flight of an SDX in orbit. And of course, it's the potential for recurring opportunities. You build one of these things, and you get RSC Energia and NASA support behind it, you can build more of them and put more of them down the road into orbit. The other reason why we're doing it is because AMSAT has a credibility issue. We have to build satellites in order to gain support of our membership. And we haven't launched anything since 2004 from a self-contained satellite perspective, and we launched, of course, SUTSAT 1 in 2006. We've made commitments to RSC Energia. We were going to do this under SUTSAT 2. Circumstances changed. We got AeroSat now, so we're still going to fulfill our obligations. And of course, we are overcoming a significant amount of adversity in that conversion from a spacesuit to a mechanical structure. And of course, again, we see this as a potential for future opportunities in space. RSC Energia has been the key behind this to date. They were the ones that supported SUTSAT 1, SUTSAT 2, and now AeroSat 1. NASA's starting to see the light. And I think if we see a successful AeroSat 1 through RSC Energia sponsorship, I wouldn't be surprised if NASA in due time will want to do similar opportunities to put U.S. students' experiments on board as well. So we have an agreement between AMSAT, NASA, and RSC Energia as to who's going to do what. We're building, constructing, or testing AeroSat 1 plus a second unit. We're actually shipping 2 units to Russia. One will be the flight unit that will be placed on the space station. The second will be identical, except it will not have the solar panels. That will be used for crew training, if you will, so that they can know how to deploy the thing once it's up there. We have to provide documentation to NASA for the payload safety review. The payload safety review panel, the PSRP, has to prove everything that's going up the space station. They want to make sure what you're building is credible and is safe and they will not allow anything to go up there without their approval. So we have to submit some pretty sophisticated documentation to show them what we're doing is legitimate, if you will. And of course, we have to arrange and pay for the shipment of the devices, if you will, to Russia. So we're paying the shipping costs, but fortunately NASA is doing the export control certification. So all the documentation for export has been done by NASA. And so that clears us a significant amount of burden in terms of getting the paperwork that needs to be done for shipping this thing to Russia. And of course, they did the PSRP, we'll talk about that, and doing a recontact analysis. They want to make sure that when the thing is deployed from the airlock of the space station, that it doesn't hit anything on the space station, solar panels, the frame, or whatever. So they're doing an analysis to tell us how we have to push that satellite out the door so that it's safe to clear the space station, which of course is a very large object. Energia, they're providing the free ride. They're putting it on a Progress cargo vessel to go to the space station. They're providing the spacecraft battery, which will power the spacecraft. It's an Orlan spacesuit battery, and we're using that because that was what the original design for SUTSAT-2 called for. And of course, they take great pride in providing that to us. And then, of course, they're providing the time and schedule for the EVA that will be conducted to release this thing during an EVA. When SUTSAT-2 became ARISSAT-1, it was a major change. Fortunately, we did not lose our slot, if you will, in terms of the Russians being willing to accept a space structure in lieu of putting something inside a spacesuit. But the ramifications of this are significant. I've just listed here a bunch of the different things we had to modify, starting in July of 2009. So basically a year. We've had to basically rebuild what we did because of the change in circumstances with the loss of the Orlan suit. They lost the Orlan suit because they were increasing the number of crew members in the space station. They were out of storage space, and anything that they didn't need right then and now, they got rid of. And if you think about it, the Orlan suit was a surplus suit that we were going to use for a frame, if you will, for our equipment. They didn't need that from their perspective, so they got rid of it. Okay. So what will ARISSAT-1 do? There'll be two different CWID frequencies. And ARIS call signs will be transmitted. These will be done where the call signs of people involved with ARIS, who have been heavily involved with ARIS over the year, their call signs are going to be transmitted randomly. It's sort of a recognition for the folks that have done so much for ARIS over the years. There will be an amateur radio transponders put on board, and there will be video from 4 different cameras converted to slow scan television. They'll be downloaded to the ground. There will be student greetings in various languages transmitted. I mean, we've gotten some of these things from all over the world: Israel and Russia, and France and Germany and Japan, and a number of countries have submitted voice recordings, which we are incorporating into this process. And then this ARISSAT itself is designed to put 4 payloads, student payloads, for experiments to be placed on the ARISSAT. In this particular case, the first launch of an ARISSAT, there's only 1 student experiment provided by Kerr State University on this spacecraft. In terms of dimensions, I've got 2 different sets of numbers to give you. The structural dimensions, and my thing here just died, is 20.5 by 10.75 inches. That's the structure. But when you add the antennas, the Kirk's experiment, and all of that, it expands to about 25 by 25 by 19. And then the deployment weight is about 25 kilograms, 56 pounds. That includes the battery and the Kursk experiment. When we ship it over to Russia, the Kursk experiment will be added in Russia, and then that structure will be shipped up to the space station. The battery will be added by the Russian cosmonauts on the space station before deployment. So we don't ship it up with the battery installed. Okay. Here's a diagram that gives you an overview of what it looks like and the components that are in there. Of course, my technology here has failed me as far as my laser pointer. The control box, which is in the lower right picture there, is the same basic design we used on SUTSAT-1. It's a timing system where you do not power up and transmit before you're a safe distance away from the space station. So it's basically a 15-minute timer. The 3 buttons or 3 switches that can be pushed that the cosmonauts will hit when they release. we running out of time? Thank you. 15 minutes. That they will release. And so this process here they'll throw the switches, they have a 15-minute timer, and by the time they deploy, it's safely away from the space station and they can start transmitting. There are 6 solar panels here that were donated by NASA. There was a project 10 years ago that was budgeted, they got panels for, but was canceled. So the surplus panels were donated to us. And of course the space frame size is based upon the size of the solar panels. That's what's driven the size of the spacecraft. We have down here the RF units. That includes both the transmitter receiver plus the software-defined transponder. The internal housekeeping unit. The MPPTs are the max power point trackers. They're basically the regulators that control the voltage coming off the solar panels. It's all PIC controlled. Here's the Kursk experiment for measuring the vacuum of space. There are 4 cameras. We have 2 mirrors for 2 of the 4 cameras, so we can look at basically 4 different directions. And then the battery, which is the Orlon battery here. And again, this is a major redesign, which we've done in basically 1 year. Here's an assembled view where you can see the antennas here, the 2-meter and the 70-centimeter antennas. And then here again, the mirrors, and then the solar panels and the 4 handles on the corners, because that's what the cosmonauts have to grab onto to safely position the satellite as it goes out the door, and they release it. As far as a block diagram is concerned for AeroSat-1, the internal housekeeping unit here is the brains, if you will. Here, the solar panels with the max power point trackers controlling the currents and voltages going into the power system. There is a power supply unit that takes those inputs from the solar panels. Over here we have the RF stuff here, the 70 centimeter and 2-meter equipment along with the SDX that's providing the modulation, if you will. 4 cameras. Then we have temperature sensors on board. We have only 1 experiment that's actually plugged in. We have room for 3 more, which maybe over time we'll get it. And then here's your Russian battery that's basically feeding into the system. In terms of the band plan, from an amateur radio perspective, it's a 16 kilohertz bandwidth transponder for both FM transmissions as well as for typical transponder use. So you have the transponder, single sideband if you will, with 2 CWIDs and 2 BBSK channels, and then the FM, which will be basically sending those messages to the ground. Okay, and then in terms of the transponder operations here, you can see the uplink and downlink correlations. The BBSK, there would be 2 different variations. I'll talk about that in a second. One is the traditional Phase 3 BPSK 400 that we used on previous satellites. But there's also a BPSK 1000 that Phil Karn, KA9Q, has developed that is a lot more robust than the BPSK 400, and we're going to be using that on AeroSat-1 and be the first time that technology will be used. The slow scan TV, as I mentioned before, will have 4 video ports, and then enough smarts in the spacecraft so it'll recognize if a blank image has been taken and discard it, and then we can shoot these things to the ground. The Kursk experiment is designed to measure the vacuum of space as a satellite deorbits. Now they want to plot the vacuum as the thing slowly over the next 9 months re-enters the atmosphere. We will be basically running this thing for 100 minutes once per day, and then we store that data, the telemetry, and then that telemetry is continuously being transmitted to the ground until the next set of measurements are taken the following day. So they will have the opportunity to get this data to the ground from the spacecraft. Here's a picture of the probe, if you will, with the connector here. It's a simple DB9 connection that plugs into our IHU, and we're basing it upon the standards and the technical specifications that were given to us as to what they needed for their inputs. We are having some technological risk in the sense that we don't have the battery, so we've had to come up with our own set of measurements as to how the battery performance will be, because there is no equivalent battery in the United States to actually test against. And of course they gave us the specs for the Kursk experiment, so we built our interfaces based upon those specs. But we haven't had an actual Kursk experiment to plug in to verify. So there is a little bit of risk because we don't have the real thing when we were building the satellite. The integration is taking place in Orlando. It's actually in a guy's garage, literally, in Orlando, not far from where the the P3D integration lab once stood. We're actually building 4 units in a prototype. So we've actually got 5 devices that we're building. 2 will go to Russia. 1 will be the flight unit. 1 will be the backup, if you will, the test unit. And we'll keep 2 in the United States for future opportunities. And so we're building them all at once because it made sense. You build it all at once, because to go back later and try to rebuild something at some point down the road can be difficult, particularly if components are no longer available. So we are basically getting close to the finish line in terms of actually getting stuff completed. We will have the flight unit ready for thermal vac next week. That's what I was last told by the project team. We've done thermal vacuum tests for the modules that are going to Russia to plus 30 degrees centigrade per day and minus 40 degrees centigrade for 4 hours. It's using the same thermal vac chamber we used for P3D, by the way. It was resurrected and put back in service. And we're using it now for the electronic components of AMSAT-1. We did find one of the command receivers was intermittent, and they're going to debug that hopefully in the next week. In terms of software development, everything on this thing is software. It's microchip, PIC stuff that's been installed. The power supply unit, the max power point triggers, and the SDX stuff is done. There is one logic device for image capture that needs to have its software updated. The internal housekeeping unit is close to being complete. They did find a problem where periodically the thing would reset itself. We're not sure why, so we're working hard to try to come up with a fix for that. And then the call sign list that I mentioned earlier, they're ready to pretty much put that into a micro SD card that'll plug in and provide that information for download. There will be ground station software developed. Again, we have coming off the spacecraft both the data from the Kursk experiment along as telemetry from the space from the ARISAT satellite itself. We'll be using 2 different BPSK channels to be able to do that. One, as I said, is the traditional 400 BPSK that we've done before. And then the CW signals itself will be sending the telemetry along with the call signs that I mentioned earlier. And in terms of the formatting of the data, there'll be 1 packet of telemetry and then 2K of bursts of 5 packets for the Kursk data itself. The software has been developed for the ground station in terms of the PC, and there is also a version to be built for the MAX platform as well. So our expectation is that we will have a complete package people can download and basically receive through their sound cards and their PCs. So you tune to the right channel, right frequency, you download the telemetry, and you'll be able to see the data both from the satellite itself along with the Kursk data. And that Kursk data will be forwarded to a central server. So as stations around the world receive this data, they can forward it to a server through the software we're providing, and then you can actually retrieve the data from the server as well. So it's meant to be, again, an educational opportunity for students to download data, look at it coming from space, and make it available to the team at Kerr State Technical University.
5 minutes.
Pardon? 5 minutes? Okay. So let me go on. I'm not going to get through all the stuff I wanted to give. But the NASA Payload Safety Review panel took place. We were rejected, not because of the technical issues that were raised, but because of documentation again. So we're going through trying to provide some of the documentation that they want. For example, the solar panels were provided by NASA. Well, they're 10-year-old solar panels, but they want some information about the development and construction of those solar panels. So we're going back to Goddard Space Flight Center and asking them for the documentation that we can then give the PSRP to make sure they're satisfied with the construction of those solar panels. The Russians have to give us data on the mounting of the ARISAT-1, the cargo vessel itself, because we need to do our vibration test based upon how the actual mounting is going to take place to the cargo vessel. We don't have the actual design of how they're going to mount it yet. So the Russians are on the hook. They understand this. They have to give us that information so we can do our vibration test to meet the expectations of a vibration test that's going to be valid. We do have an agreement with Wallops Island, Virginia, to do the vibration testing there. So until we get the test data we need, or the test parameters we need from the Russians, we cannot schedule the actual vibration test. But once we have that information, we will do it at Wallops. Our expectation, despite all of this, is that we will upload to the International Space Station on a Progress vessel that's scheduled in December, and we are expecting that they will place us on an EVA that's in February. That is not in stone. We have not been formally manifested, but that's the talk that is going on right now in terms of what we expect based upon the current situation. I do want to mention from Gaston Bertel, who's the ARIS-I chairman, 2 items that he wanted me to mention as far as ARIS is concerned. One is the relocation of the VHF and UHF Ericsson handhelds to the Columbus module. You recall that there are amateur radio antennas now mounted on the Columbus module. And then he's also mentioned to us about discussing with ESA the possibility of installing a ham TV equipment on Columbus. This is a concept at this point. It is not cast in stone, but it is being discussed. So we'll see how that develops over time, but that would use the existing S-band capability of the LS-band patch antennas that were installed in the nadir of the Columbus module itself. A couple of quick things on AO7. 24/7 illumination right now, so that basically working on the timers that were built into the spacecraft. And you can see it alternates from mode A to mode B relatively reliably. If you want to check the status, here's the website of dcar.org. This is where this came from in terms of showing you the status of AO7 mode A and mode B. And it's generating a lot of interest. It continues to be used quite extensively. On AO51, Drew Glassburner, our VP of Operations, wanted me to mention that, of course, we've been in a situation where we've had relatively little eclipses, but now we're getting to the point now in 2010 going on where we're going to have more and more eclipse situations going on. We're more in darkness. So it's becoming an issue in terms of managing the power of the spacecraft itself. So that was why they're incorporating a new PL mode to try to manage the transmitter, if you will, to ensure that we don't waste power in eclipses because of the longer eclipses. And they've come up with some power management software that will hopefully help maintain the health of the spacecraft. Okay, thank you. You may recall there was an Apollo 11 special event last year in conjunction with the 40th anniversary of the first moon landing. This was a unique opportunity to sort of publicize that anniversary, doing some of the same things that was done in 2008 with Sputnik. So there were audio messages relayed by volunteer L-band stations on a secret uplink in PL tone, and those messages included a Robot 36 SSTV image. And if you caught that information and downloaded it, this is what it looked like. So here's 3 different images from 3 different stations that received the imagery that was sent off AO51. And of course, those folks that did that then received a QSL card that commemorated the event. So that was a pretty popular event on AO51. I'm going to end it here. I do want to show one slide. I'm going to reach through the end because I got to give my it's not on this version. I was going to mention the AMSAT North America Symposium takes place the weekend of October 8th in the Chicago area at Elk Grove, Illinois. If you have any interest in coming to the States, I think you'll find it very interesting. And we do things a little bit differently, as I think Jim mentioned yesterday. But I think you'll find it very, very interesting and very entertaining. And you'll hear more about ARISat-1 and our Fox CubeSat, which we're starting to look at seriously. We announced it last year, but we held off because of the focus on ARISat-1. But now that that's coming to a conclusion, we're going to start turning to on Fox. Okay. Thank you, sir.
Thanks a lot. Thanks, Barry. And as I mentioned earlier on, Barry's probably one of the most approachable people within AMSAT. So he might regret me saying that, but certainly from the point of view of welcoming newcomers, he's really such a benefit to the AMSAT community, for which I'm sure we all thank him. And if you don't believe ITAR is, I've got a question. Yeah, quick thing from me. If you don't think ITAR is real, certainly I remember about 5 years ago I was actually going towards STEC to see Neil, who's in the audience somewhere here, and in the paper that morning I read on the plane in the Times that the White House had said that Martin Sweeting was one of the top 10 most dangerous people in the world after he'd just This is a true story. After he'd just been to China and divulged some space-related information, I also had an ITAR interview about 18 months ago, where I was asked some questions about the SDX. So this is real, and I believe that Graham actually provided the handles for ARISSAT. Is that right? Sorry, AMSAT-UK. So AMSAT-UK provided the grab handles for the ARISSAT there. So there you go. So we're into fabrication and hardware. Okay, we've got some questions on the internet. Graham, have you got a microphone or over there? Hang on.
G3ZHI wants to know why the ISS is not in permanent repeater mode 2 to 70 rather than just being on packet. And one other question, how long will SUTSAT-2 or ARISSAT last in orbit? That's from Paul 2E1 EUB.
Okay, I cannot answer the question about the status of the ISS itself. I'm not involved with the operation of those equipment on board the ISS, so I can't provide an answer. As far as the duration of ARISSAT-1, it's going to be 9 months to a year. So from a perspective, it's just like SUTSAT-1. It was, it deorbited. I think it was about 12 months after it was released. We expect the similar situation with ARISSAT-1. The drag will be different. It's a different structure. We really haven't looked at, a real number in terms of how long it's going to last. But given the height of the ISS and the downward movement, when they release it from the space station, they're likely going to push it down and away from the space station. So that'll push you, slow you down, and it will put you into a lower orbit. So over time, it's going to deorbit, and we expect that it'll be 9 months to a year. By the way, one of the things that NASA came to us with was they wanted a list of all the materials on ARISSAT-1, and the idea was they wanted to do a deorbit analysis because they want to make sure nothing hits the ground. So we had to give them a list of all the materials going to all the PC boards, the battery, solar panels, so they can do analysis to make sure everything's going to burn up, if you will, when it hits the atmosphere and does not hit the ground.